Today, we won't journey to distant galaxies. Instead, we'll turn our gaze to our cosmic backyard. That's right, the solar system we call home. You might think you know everything about the solar system: Mercury, Venus, Earth, Mars. But do you truly understand these neighbors and the amazing secrets they hold? Did you know? Look up at the night sky and ponder this. In the vast Milky Way, what fate bound humanity and Earth to this corner called the solar system? We know there are 8 planets in the solar system, but do you really know them? The extreme temperature swings of Mercury, the hellish atmosphere of Venus, the ancient oceans of Mars, the violent storms of Jupiter, the elegant rings of Saturn, and the distant, icy outer worlds. Explore their unique personalities, incredible extreme environments, and their significance for our understanding of the universe. Today, we'll embark on a deep space journey, traversing billions of kilometers to unlock the ultimate mysteries of the solar system's 8 planets one by one. In this video, we'll not only admire their beauty but also analyze their formation mechanisms, extreme environments, and their profound impact on the existence of life on Earth. Let's start with Mercury, the planet closest to the Sun, and set off on this unprecedented in-depth tour of the solar system. Mercury is the closest planet to the Sun and the smallest in the solar system, even smaller than Ganymede and Titan. As a rocky terrestrial planet, it is famous for its extreme temperature changes and desolate surface. Extreme temperature fluctuations. Mercury orbits the Sun at a minimum distance of just 46 million kilometers. It has almost no atmosphere, only a thin exosphere that cannot effectively retain heat or distribute temperature. This results in the most extreme surface temperature swings of any planet in the solar system. The day side can reach up to approximately 430 degrees Celsius, while the night side plummets to around 180 degrees C. A slow and unique rotation. Mercury rotates extremely slowly, with a special 3:2 orbital resonance between its rotation and revolution. It rotates 3 times for every 2 orbits around the Sun. This means a solar day on Mercury, from sunrise to the next sunrise, lasts about 176 Earth days. Surface features and interior. Mercury's surface is covered with dense craters, much like the Moon's, indicating its geological activity ceased billions of years ago. Its most prominent landform is the vast Caloris Basin. Surprisingly, despite its small size, Mercury has a relatively large, iron-rich metallic core that occupies 83% of the planet's radius, making it the second densest planet after Earth. Venus is the closest planet to Earth, known as Earth's sister planet. Due to their similar size, mass, and average density, their environments are vastly different. Extreme environment. Venus is defined by its extremely harsh conditions. Its average surface temperature reaches approximately 475 degrees Celsius, hotter than Mercury, making it the hottest planet in the solar system. Meanwhile, its atmospheric pressure is 92 times that of Earth's sea level, equivalent to the pressure 900 meters deep in Earth's oceans. Runaway greenhouse effect. Venus's extreme heat stems from a runaway greenhouse effect. Its atmosphere is extremely dense, composed mostly of carbon dioxide, over 96%. This thick layer of carbon dioxide acts like a heavy blanket, efficiently trapping heat from solar radiation and preventing it from escaping back into space, causing the planet's temperature to soar. Atmosphere and rotation. Venus is shrouded in a thick layer of sulfuric acid clouds that not only block direct observation of its surface, but also produce corrosive sulfuric acid rain in the upper atmosphere. Venus rotates extremely slowly, with a rotation period of 243 Earth days, longer than its orbital period of 225 Earth days. It is also the only planet in the solar system that rotates retrograde, from east to west. In short, Venus serves as a natural laboratory for studying climate change and the impacts of the greenhouse effect, demonstrating the extreme consequences that can arise from different evolutionary paths of a planet similar to Earth. Earth is the only known planet in the universe to harbor life. Formed approximately 4.54 billion years ago, it is the largest of the solar system's 4 terrestrial, rocky, planets. Conditions of the blue marble. Earth's ability to sustain life is attributed to several unique key factors: liquid water, About 71% of Earth's surface is covered in water, the basic solvent for life, and the reason Earth is called the blue marble. Suitable temperature. Earth lies within the solar system's habitable zone, keeping surface temperatures just right for water to exist in liquid form. Atmosphere. Earth's atmosphere is mainly composed of nitrogen and oxygen, providing the oxygen needed for biological respiration. The ozone layer within it also effectively blocks harmful ultraviolet radiation from the sun's magnetic field. Earth's internal dynamo effect generates a strong magnetic field, forming the Van Allen radiation belts that deflect charged particles from the solar wind and protect the atmosphere from being stripped away. Structure and dynamics. Earth's internal structure is layered: crust, mantle, and core. Plate tectonics is the primary dynamic process on Earth's surface, driving earthquakes, volcanic eruptions, and continental drift to reshape the landscape. Earth's rotation causes day and night, while its revolution around the sun and the tilt of its axis, approximately 23.5 degrees, bring about seasonal changes. Earth has one natural satellite, the Moon, which plays a decisive role in Earth's tides and stabilizes its axial tilt. Mars is the planet on which humanity places the most hope. It is the known planet in the solar system most similar to Earth. Its red color comes from iron-rich oxides, commonly known as rust. Abundant evidence suggests that billions of years ago, Mars was a warm, wet planet with oceans and rivers. Images sent back by rovers have revealed ancient riverbeds, delta sediments, and hydrated minerals. Today, however, Mars has an extremely thin atmosphere and extremely low surface temperatures, with water existing only as ice underground and in polar caps. Scientists believe Mars' magnetic field disappeared early in its history, allowing the solar wind to strip away most of its atmosphere, transforming it from a warm world into today's frozen desert. Human exploration of Mars aims not only to find signs of life, but also to understand planetary evolution and prepare for future human colonization. Jupiter, the guardian of the solar system. Its mass is 2.5 times that of all the other 7 planets combined. If Jupiter were 80 times more massive, it could ignite nuclear fusion and become a second Sunday. Its powerful gravity has cleared a large number of asteroids and comets from the inner solar system, partially protecting Earth from catastrophic impacts. Jupiter is also a world of storms. Convection in its atmosphere creates spectacular banded cloud formations and cyclones. Most famous is the Great Red Spot, a superstorm that has lasted for at least 350 years, large enough to swallow 2 or 3 Earths whole. Its Galilean moons, Io with its volcanic activity, Europa with its subsurface ocean, considered one of the most likely places for extraterrestrial life in the solar system, and Ganymede, the largest moon in the solar system, bigger than Mercury. Each form an independent microcosm. Saturn is the second largest planet in the solar system by volume and mass, after Jupiter. As a gas giant, it is famous for its magnificent ring system, making it one of the most iconic celestial bodies in the solar system. Composition and structure. Saturn is mainly composed of hydrogen and helium, like a giant balloon. Its average density is lower than that of water, making it the least dense planet in the solar system. Its core is surrounded by a layer of metallic hydrogen, with molecular hydrogen in the outer layer. Unique ring system. Saturn's ring system is its most distinctive feature. Stretching hundreds of thousands of kilometers wide, the rings are extremely thin, usually no more than 100 meters thick. They are not solid but consist of billions of tiny ice particles and rock fragments, ranging in size from micrometer-sized dust to meter-wide boulders. These fragments are captured by Saturn's gravity and orbit its equator, forming complex structures with multiple main rings, such as A, B, and C, and gaps. Moons and climate. Saturn has a large number of natural satellites, 146 confirmed so far. The most famous is Titan, the only moon in the solar system with a dense atmosphere and liquid lakes on its surface, making it a key target for studying the origin of life. Saturn's atmosphere is filled with violent storms, with wind speeds reaching up to 1,800 kilometers per hour, forming striking banded structures. Uranus is one of the 4 giant planets in the solar system, classified as an ice giant alongside Neptune. Discovered by Sir William Herschel in 1781, it was the first planet found using a telescope. Unique rotation and structure. Uranus's most notable feature is its extreme axial tilt. Its rotation axis lies almost parallel to its orbital plane, with an inclination of approximately 97.77 degrees, meaning it essentially orbits the Sun on its side. This unique orientation causes its poles to alternate between long, extreme days and nights, with one season lasting about 21 Earth years. Its main components are hydrogen, helium, and large amounts of icy substances such as water, ammonia, and methane. Methane absorbs red light and reflects blue-green light, giving Uranus its unique cyan appearance. Uranus has a thin ring system consisting of 13 known rings and at least 28 natural satellites, the largest 5 being Miranda, Ariel, Umbriel, Titania, and Oberon. Atmosphere and temperature. Uranus's atmosphere is one of the coldest among planetary atmospheres in the solar system, with minimum temperatures dropping to approximately -224 degrees Celsius. Despite being far from the Sun, it emits very little internal heat, a mystery that scientists are still investigating. In summary, Uranus is a fascinating planet known for its unique sideways rotation, icy internal structure, and pale blue appearance. Neptune is the farthest known planet in the solar system. Despite its extreme distance from the Sun and extremely low temperatures, it boasts the most violent storms and highest wind speeds in the solar system. Wind speeds can reach an astonishing 2,400 kilometers per hour, several times faster than the strongest typhoons on Earth. Scientists believe these extreme winds are driven by the huge temperature difference between its internal heat and the extremely low external temperature. Neptune's moon's its main moon, Triton, orbits retrograde and is slowly spiraling toward Neptune. This means that in billions of years, Triton will eventually be torn apart by Neptune's gravity or collide with the planet. Triton is also one of the coldest objects in the solar system, yet it has rare eruptions of nitrogen geysers on its surface, truly astonishing. We've completed this deep journey across billions of kilometers. From the scorching Mercury to the hellish Venus, from our unique blue home, Earth, to the once wet Mars, from the violent Jupiter to the elegant Saturn, and on to the distant, icy worlds of Uranus and Neptune. Each planet is an independent cosmic laboratory, telling the magnificent story of the solar system's billions of years through its evolutionary history. The greatest insight from this in-depth analysis of the solar system's 8 planets is just how lucky we are. Earth's ability to become an oasis of life is the result of countless coincidences and the laws of the universe working together. It tells us that life is a fragile yet precious existence in this universe. Exploring other planets is exploring ourselves. Future space missions, whether studying Venus's atmosphere, drilling into Mars's subsurface ice, or probing Europa's subsurface ocean, will continue to uncover the ultimate mysteries of the solar system. If you were amazed by this cosmic journey, please like this video and tell me, among these 8 planets, which one do you think has the most extraordinary fate? Don't forget to subscribe to my channel and hit the notification bell so you won't miss our next cosmic exploration journey.